So now we're going to get to polygons and angles, and that is the very first lesson in this packet that I have uploaded on Blackboard under Project 1. So let's start with that. And does everybody have a handout now or not?
I can print another one if somebody needs it.
Okay, can you print another one, Andrea, please? Because these really don't look that well.
Do you want me to go ahead and print it?
Yeah, please.
I just clicked and save it slow on
You're
toner,
fine.
so.
Yeah, it says that every time that. Like
But
3 years ago.
when you print it, did it print okay, Andrea? Can you see? Yeah, it's fine. Okay. Okay, so I'm on page 5 on that handout, and this lesson, there are 10 lessons here. I'm going to do the first 3 for you today with you, and then you will do the rest as a project. So let's start with polygons and angles. Okay, so what's the definition of a polygon?
Is a closed figure with
Yeah.
made up of line segments.
Yes, so it has to be a closed figure, right? Something like this, for instance, is not a polygon. If you, if you have something like that, that will not be a polygon, right? And it has to consist of line segments. So your most basic polygon will be a triangle, and then you can, so this will be a 3-gon, essentially. This would be a 4-gon, and you can continue and, graph more polygons, but that's what we are going to look at right now, polygons and angles. So I mentioned that the most basic polygon is called, is a triangle, right? Because that's when you will get a closed figure. So let's go and create a triangle. So I'm going to just start a whole new, I'm going to go to File. If you go over to the right, you can just go to New. Just click on New, and then I'm not going to save that. You're welcome to save it, but I think they will actually delete things from these computers every day. So if you save on this computer, make sure that you email it to yourself, because they will delete things from here. Okay, so I just started a new page, and what I also wanted to show you is the view here. To the right, you will have the view, and it's way over here. And here you can decide whether you want a grid, for example. If you want a grid, sometimes that's helpful to use if you want to be very, specific about how it's going to look like.
As a polar too, that's pretty cool.
What?
As a polar grid.
Yeah. So, or if you are, if you are not interested in that, you can just click on the white, and it will just have the axis. Okay, so for now, we will play with the grid a little later. Let's just do this for now because we want to create a triangle. So let's create a triangle. So what you do is you go over to the polygon icon over here. It has a little triangle right there. Click on polygon. And then what's nice about Geogebra is you actually have to think, how would you create a polygon? A polygon is determined by its 3 vertices, a triangle. So you're going to plot 3 vertices. And so it has to be a closed figure, so you will have to close that up at A, and there you have your polygon. And now if you look to the left, you will see you have point A is going to be this point, 5.5 and 3.2, so it will tell you the vertices. Point B is that point, point C is that point. If you hover over the triangle, it will tell you it is the triangle. They call it poly 1, and then what do you think is this number over here?
Perimeter.
Area.
Yeah, that's actually the area. Yeah, so it will tell you the area over there. Okay, so now we have our polygon, and yours is probably going to look different than mine, but what we're going to do now is we're going to measure the angles, the interior angles. And what do we know about the interior interior angles of a triangle.
Add up to 180.
180.
They add up to 180, right? So let's see if that is in fact true. So we're going to go to the angle tool. It's this one over here. Click on angle. And then click on, I want to measure angle B, so I'm going to click on A, B, C. I've measured the exterior angle, I'm sorry. And there's a...
You have to go the other way.
Yeah, sorry, I know that there's a trick. Yeah, I did this the other day and I'm like, what is going on? And that is what's going on. So you can see it will measure it, it's 44.95. And then if I want to measure B, let's try it this time. It's going to measure the inside, which will be 70.68. And then to measure A, I will click on B and then A and then C. Vertex C. Okay, so now what happened here is you actually constructed, the angles were constructed for you to the left. So you have alpha, oh sorry, alpha is the exterior angle. So let's just, you know, don't worry about that for now. Yeah, let's unclick it, yeah. So beta, gamma, and delta. And let's say you want to show your students that, well, the sum of the interior angles of a triangle is 180. Let them, in the input bar, add those angles. So we have beta. If you click on this plus sign over here, no, if you just click on the input bar and you go down here, you will see the Greek letters are down here, alpha, beta, gamma. So we created, what was it? Beta, gamma, and delta. So we're gonna have beta plus beta plus gamma plus alpha. No, delta, sorry, not alpha, it's delta. And that is gonna equal, let's say S, or let's just say equal. I think it can just do equal. Yeah, there it is. So it will create epsilon, and epsilon is going to be the sum of that. If you hover over epsilon here, it will tell you what it is. It's going to be the sum of beta plus gamma plus delta. Everybody okay with that? And so, and it tells you that epsilon, that angle that was created, equals 180. And now you can actually experience the first interactive or dynamic value of GeoGebra. So move around the point A, for instance. Let's click on select, move, just to be sure, and then click on, let's move around A. And if you would move around A, you can see that your beta and gamma, the angles will change, right? You can see how I'm moving around and how the angles change. But epsilon, which is the sum of those interior angles, I mean, that value doesn't change. So it's a way, and you know, you can move around beta, you know, and see how the values change, because you're changing your angles, but the sum of the interior angles doesn't change.
On the formula, I typed it in, it didn't give me the epsilon equals 180. Could you show the formula again?
Oh, I just basically said beta, so what I... Did it create beta or alpha? Because I made that error at the beginning, Doug. I'm going to turn